Have you ever felt like you're just drowning in information? Everywhere you look, there's this constant torrent of data, numbers, endless streams of digital noise. It's everywhere. But making genuine sense of it all, truly understanding what it means, and then extracting something useful, it can feel like trying to catch water with a sieve, right? From the smart thermostat quietly humming away in your living room to maybe the complex traffic lights coordinating city flow, we're surrounded by technology that's constantly buzzing, collecting, sending out signals all the time. But what actually happens to all that raw data? How do those seemingly meaningless bits and bytes transform into something, well, profoundly meaningful, something powerful and actionable? That's precisely what we're digging into today. We're embarking on a deep dive into the fascinating, ever-expanding world of IoT data. That's the massive, continuous streams of information generated by all those smart devices around us. We've meticulously curated a fantastic stack of insights for you from our sources for this. And our mission today is basically to cut through the noise, bypass that overwhelming data deluge, and give you a direct shortcut to understanding how raw IoT data transforms into potent operational intelligence and real strategic value. So get ready for a journey. We'll go from just comprehending the sheer volume of this data to the remarkable tools that actually tame it, the inevitable challenges you'll likely face, and the really mind-bending future possibilities that are already starting to take shape.
And that mission is, frankly, absolutely critical in today's landscape. It really is. While data is often called the new oil, and you hear that a lot, it's not just having barrels of the raw stuff that provides any real value, the true power, the real aha moment. It comes from the ability to refine it, to truly understand its nuances, and then, crucially, to apply those insights in a way that drives tangible change, real results. This deep dive, I think, will illuminate precisely how diverse pieces of information, often seemingly disconnected or maybe too granular to matter on their own, can be expertly connected, analyzed, and visualized to form a crystal clear, actionable picture. And this enables smarter, much more informed decisions across, well, virtually every sector. It's fundamentally shifting how businesses operate and how we all interact with our connected world. You're about to see those intricate connections really come to life.
Okay, right. Let's unpack this then. Let's start by trying to wrap our heads around the foundational element here, the sheer, almost overwhelming scale of IoT data. If you thought the internet was vast, well, prepare yourself. This is arguably an even more explosive reality. We are talking about an unprecedented deluge of information, and it's growing at an astonishing, almost unimaginable rate.
Yeah, what's truly fascinating here isn't just the current volume, though that's huge. It's the relentless velocity and the acceleration of this explosion. This isn't some slow, gradual buildup. It's a constant, exponential surge. It's really redefining our digital footprint. The projections alone are, frankly, staggering. By 2030, we're expected to have well over 30 billion connected devices deployed worldwide. 30 billion. Just pause for a moment and really consider that number. Each one of those devices, whether it's a tiny embedded sensor meticulously monitoring conditions in a factory, or maybe the highly complex systems within a self-driving car, each one is continuously producing data. It's not just a static snapshot like a photo, it's dynamic, an uninterrupted stream of information, a kind of perpetual digital heartbeat emanating from, well, every corner of our lives and industries.
30 billion devices. It's genuinely difficult to even conceptualize that scale, isn't it? To help you visualize it, maybe imagine your own smart home devices. Your smart speaker responding to commands, your thermostat adjusting temperatures, perhaps even your refrigerator tracking its contents or, its energy usage. All of these are constantly talking, generating strings of data about their state, their environment, their interactions. Now, sort of extend that mental image out to every smart appliance, every wearable fitness tracker, logging your steps and heart rate, every single industrial sensor embedded deep within some massive manufacturing plant, predicting machine health, in every GPS unit, actively tracking a whole fleet of trucks out on the road. It's an absolutely immense, always-on, global data conversation happening simultaneously across billions of endpoints. The sheer magnitude means we're not just dealing with good data anymore, are we? We're navigating a genuine data ocean.
Exactly, a data ocean. And the sources feeding into this ocean are incredibly diverse. It truly reflects how pervasive IoT has become across virtually every domain. You've got personal wearables like the fitness tracker maybe on your wrist right now, tirelessly sending data about your heart rate, sleep patterns, activity levels, all that stuff. Then shift to the industrial realm. Think about sensors meticulously embedded in factory machines. They're monitoring vital parameters, vibration, temperature, pressure, operational uptime, all absolutely crucial for preventing those costly breakdowns and optimizing production. Your smart appliances at home refrigerators, washing machines, they provide nuanced insights too. Usage patterns, performance, maybe even alerting you to maintenance needs, and of course, connected vehicles. They're an enormous source, generating continuous data from GPS for precise location, optimal routing, to detailed engine diagnostics, real-time tire pressure monitoring, even insights into driver behavior for safety and efficiency. Each of these categories, plus countless others, contribute significantly to that staggering volume and variety of information we're talking about. Now, what's also critical for our deep dive today, I think, is understanding how fundamentally different this IoT data often is from the traditional enterprise data you might be more familiar with. Think about, say, the structured relational data you typically find in your CRM system or your financial databases. Nice, neat rows and columns. IoT data, in contrast, is frequently unstructured or maybe semi-structured. It could be raw sensor readings, high-def video feeds, complex audio clips, or even just free-form text from device logs. A key defining characteristic is its incredibly high volume and velocity. It's generated continuously, often in bursts, and very frequently needs processing at near real-time speeds. And most importantly, it is predominantly time series data. This means data points are collected at specific, often very rapid intervals of time. This allows you to track precise changes, observe patterns over durations, and crucially, predict future states. This unique time series nature is really what allows us to go beyond simple observation and unlock truly predictive, even prescriptive capabilities, you see. And this explosive growth, two pivotal technologies are not just enabling this, they're actively accelerating this data flow. 5G connectivity and edge computing. 5G provides the ultra-fast, ultra-reliable, and critically, the low-latency communication needed for billions of devices to transmit data reliably and quickly. No bottlenecks. It's like upgrading our data infrastructure from, I don't know, a narrow, congested country road to a multi-lane, high-speed superhighway built specifically for massive data throughput. Edge computing, on the other hand, it revolutionizes where the data processing actually occurs. Instead of sending everything back to some distant, centralized cloud for analysis, that edge computing allows data to be processed much closer to its source, literally at the edge of the network. This could be right on a smart factory floor, or within a connected vehicle, or even on a local gateway in a smart building. This proximity significantly reduces latency, enabling faster insights and more immediate autonomous actions, which is absolutely crucial for applications where that real-time response is paramount.
Right. So given this truly immense, always-on ocean of data, what does this all mean for us? Why does this continuous flow of raw bits and bytes actually matter if it's just, well, raw bits and bytes? It matters because that raw information, by itself, it's largely like a pile of unrefined ore, isn't it? It holds immense potential, sure, but it's not gold yet. And that's precisely where the transformative power of analytics steps in.
Yeah.
It's the critical key, the key to unlocking that inherent value.
You've hit on a crucial distinction there, absolutely. Raw IoT data, exactly as you put it, holds very limited value on its own. It's merely a collection of numbers, signals, maybe discrete events. But it's through the sophisticated, transformative power of analytics that this raw data can be refined, distilled, and ultimately turned into a powerful decision-making engine. It's the engine that converts mere potential into truly tangible, impactful outcomes. Organizations leverage analytics in several profound and often really revelatory ways. They use it to uncover incredibly subtle yet critical patterns. For instance, discerning what constitutes perfectly normal equipment behavior versus the very earliest indicators of an anomaly in a factory setting. Subtle shifts. They detect deviations and anomalies, like a sudden, unexpected temperature spike in a server room that could signal an imminent hardware failure or even a fire risk. Analytics also enables highly accurate forecasting of demand, like predicting energy needs across a smart grid based on historical usage patterns, real-time weather conditions, maybe even predicted occupancy levels, and crucially, it optimizes processes across the board. From dynamically streamlining a complex manufacturing line to fine-tuning energy consumption in a sprawling smart building for maximum efficiency. Consider a seemingly simple sensor reading just a number indicating, say, vibration frequency. On its own, that number tells you almost nothing, right? But with advanced analytics, that simple reading, when integrated with historical data and machine learning models, it can be transformed into a precise predictive maintenance alert. If the vibration patterns start to subtly deviate from the established norm, or maybe show a progressive degradation signature. Analytics can flag it, indicating a potential issue weeks or even months before a catastrophic breakdown occurs. This isn't just about avoiding a problem, it allows maintenance to be scheduled proactively during planned downtime. It eliminates the cost and chaos of reactive emergency repairs. This fundamentally shifts maintenance from a costly reactive scramble to a strategic proactive intervention. It redefines operational resilience and saves substantial sums of money. The insight here isn't just knowing what is happening, but what will likely happen and what you can actually do about it. And this goes far beyond just the technology itself. It's about cultivating a fundamental shift in how entire organizations operate. It's about fostering a pervasive data-driven culture, empowering engineering and operations teams, the very people on the ground making things happen, to make informed decisions based on solid, real-time data, rather than relying purely on intuition or fragmented information. When these insights are not only valued but also made easily accessible, teams can react with unprecedented speed, innovate more effectively, and continuously drive improvement. The tangible benefits are stark. Significantly reduced operational costs because you're preventing failures and optimizing resource use, and a remarkable boost in overall efficiency, making processes leaner, more predictable, and ultimately far more productive. It's really moving from guesswork to informed certainty.
That foundation of analytics is absolutely crucial. I see that. But it raises a natural question, doesn't it? But all this data flowing in and this clear, undeniable need for powerful analytics to make sense of it, how do organizations actually implement this? What are the practical tools and approaches available out there? To truly tame this data beast and convert it into that operational gold we're talking about.
You're absolutely right. The how is exactly where the rubber meets the road, where strategy meets execution. And there are numerous tools and platforms specifically designed to support IoT analytics. They span a remarkably wide spectrum, actually. You can find everything from highly robust, open-source software stacks that you build and manage yourself, offering immense flexibility, all the way to fully managed cloud solutions that handle much of the underlying infrastructure and complexities for you. The crucial point here, as our sources really emphasize, is that selecting the right stack isn't a one-size-fits-all decision. It definitely isn't. It hinges on a handful of key interconnected factors specific to your organization's unique needs and, importantly, its strategic objectives. When we examine the landscape of common tools, there are a few heavy hitters that consistently appear as foundational components in successful IoT analytics architectures. For handling those immense high-throughput data streams, especially when you need to ingest massive volumes of incoming data quickly, reliably, and with guaranteed delivery, Apache Kafka is pretty much an industry gold standard. It's not just a data pipeline. It's a distributed streaming platform designed for incredibly high throughput and fault tolerance, meaning it can ingest and reliably deliver billions of sensor events per second without dropping a single byte, even if a server fails. That's critical, especially when you have devices constantly streaming data from countless endpoints. Then, for efficiently storing and querying all that specialized time series data we discussed, the temperature logs, vibration frequencies, GPS coordinates time-stamped every second, InfluxDB is a widely popular choice, very popular. It's engineered from the ground up specifically for this type of rapidly changing time-stamped information, optimized to handle massive write volumes and then query that data incredibly fast, letting you see historical trends or real-time performance over minutes, hours, or even years with ease. And for making sense of it all visually, bringing those complex data patterns to life, Grafana stands out. It's an immensely powerful open source tool for creating interactive dashboards and visualizations. Helps you see your data patterns at a glance, often used by operational teams for real-time monitoring. Beyond these sort of foundational open source components, the major cloud providers, they offer their own integrated end-to-end solutions. These can significantly simplify many aspects of IoT data management and analytics. You have Azure IoT Hub and Azure IoT Central from Microsoft, AWS IoT Core and AWS IoT Analytics from Amazon Web Services, and Google Cloud IoT from Google. These platforms offer comprehensive services, seamlessly connecting devices, ingesting data, and then providing the tools for processing, storing, analyzing it all within a single scalable ecosystem. They can be incredibly powerful for organizations that want to leverage the immense scalability, global reach, and managed services of the cloud, reducing their own operational burden. Now, when it comes to picking the right platform from this whole array of options, you absolutely need to consider several critical criteria. First, scalability. Can the chosen solution not only handle your current data volume, but more importantly, can it effortlessly scale to accommodate future data growth? Because as we've established, that growth is relentless and compounding. It won't stop. Second, latency requirements. How fast do you genuinely need the insights? Are immediate sub-second real-time alerts absolutely critical for safety or operational control? Or are daily, weekly, maybe even monthly reports sufficient for your strategic needs? This directly dictates the underlying architecture. Third, integration. How well does the platform connect with your existing enterprise systems, your ERP, your legacy databases, your other operational tools? Seamless integration is crucial to avoid creating isolated data silos. Nobody wants that. Fourth, cost. This isn't just licensing or subscription fees. It also encompasses infrastructure costs, ongoing operational overhead, and the cost of the human resources needed to manage and optimize it. Finally, and perhaps most crucially, team expertise. Does your internal team possess the necessary skills and knowledge? Can they effectively implement, manage, and continuously optimize the chosen platform? A powerful tool is ultimately only as effective as the team that wields it, right? And there's a fascinating sort of democratizing emerging trend we're seeing here too. It's the significant shift towards low-code and no-code analytics platforms. These tools are meticulously designed to lower the barrier to entry, making it much easier for a broader range of users, even those without deep programming or data science expertise, to build and deploy analytical solutions. This effectively democratizes data access and analysis, leading to faster adoption of IoT initiatives and enabling more teams across an organization to extract value from their IoT data much more quickly without needing to write tons of custom code. It's about putting the power of insights directly into the hands of those who need it most.
That's a really comprehensive overview of the tools available. It makes it clear there's likely a solution for almost any need, really, from bespoke open source builds to fully managed cloud ecosystems. But once you have the tools, the next critical decision seems to be deciding when you need the insights. Are we looking for immediate alerts that tell us something is happening right now? Or are we more interested in uncovering long-term trends and historical performance? This brings us to, I guess, a fundamental and essential distinction in IoT analytics, real-time versus historical analytics.
Understanding this distinction is absolutely essential, yes, because it profoundly impacts your architectural choices, your specific tool selection, and ultimately the practical value you can derive for any given use case. It's not about one approach being inherently superior to the other. It's about choosing the precise right approach for the specific problem you're trying to solve. Real-time analytics, that's entirely about immediacy and responsiveness. Its primary purpose is to continuously monitor critical infrastructure and provide instantaneous insights that enable immediate action. Think about the intricate task of managing modern power grids, where immediate fluctuations in supplier demand need identification and addressing within milliseconds to prevent widespread outages, milliseconds. Or consider complex factory lines where a sudden machine malfunction requires an instant sub-second alert to prevent cascading damage, costly downtime, or even safety hazards. Concrete examples include things like fleet tracking, where you need live, second-by-second location updates of vehicles for dynamic dispatching and optimal routing decisions. Or sophisticated security systems generating immediate alerts if an intrusion or breach is detected. These are scenarios where every millisecond matters. A delayed insight is effectively a missed opportunity, or worse, a potentially catastrophic problem. Historical analytics, on the other hand, is about looking back, seeing the bigger picture and learning from the past. Its purpose is to meticulously analyze long-term trends, perform rigorous performance benchmarking, and inform strategic planning. This involves examining enormous volumes of past data over extended periods, months, years, to identify enduring patterns, correlations, and anomalies that might not be visible in those real-time streams. For instance, a utility company might analyze years of energy consumption data across an entire city to identify precise seasonal patterns, daily peak loads, or even the impact of specific weather events. This allows them to better predict future demand, optimize resource allocation, and plan infrastructure upgrades strategically. Or a manufacturer could evaluate the performance of a specific piece of equipment over its entire life cycle, using years of operational data to identify common failure points, optimize preventative maintenance schedules, or even inform future product design improvements. It's fundamentally about learning from the past to make more intelligent, data-driven decisions for the future. But the reality for many forward-thinking organizations, though, is that they don't exclusively choose one over the other. They wisely embrace hybrid approaches. They skillfully combine streaming analytics for that immediate, critical, real-time insight and rapid response, with batch analytics, which processes those vast historical data sets in larger chunks for deeper strategic understanding. This allows them to effectively get the best of both worlds. They can react instantly to critical events as they unfold, while simultaneously gaining a comprehensive strategic understanding of their operations over longer time horizons. It's a powerful combination that provides truly holistic operational intelligence.
That distinction between real-time and historical is incredibly helpful for framing the win of insights. really clarifying. But, no matter how amazing your raw data is or how sophisticated your analytics engine, if you can't see and understand those insights clearly and quickly, they aren't truly valuable, are they? Imagine having a detailed treasure map written in a language you don't speak, or using symbols you can't decipher. You know the treasure is there, maybe, but you simply can't find it. This is precisely where effective data visualization techniques become absolutely crucial.
You've truly highlighted a core truth of data analysis there. Absolutely. The final critical mile of extracting value from data is invariably its presentation, how you show it. Making complex data understandable and accessible to diverse stakeholders, both the technical experts and the non-technical executives, is just as crucial as the initial data collection and the subsequent sophisticated analysis. In fact, if the hard-won insights aren't clearly communicated and readily accessible, all the immense effort invested in data collection and advanced analytics is, well, largely wasted. Data visualization allows stakeholders to quickly grasp insights at a glance. When you're dealing with millions, even billions of individual data points, raw numbers are just overwhelming, largely meaningless to the human brain. But when that data is thoughtfully transformed into a meticulously designed chart, a clear, intuitive graph, or an interactive, well-structured dashboard, patterns, anomalies, and critical trends leap out instantly. They become obvious. This capability allows for what we describe as grasping insights at a glance, enabling rapid understanding and much faster decision-making. This is particularly vital when it comes to visual storytelling. Dashboards are far more than just static collections of charts. They are dynamic, interactive tools specifically designed for telling a compelling, data-driven story. In executive communication, where time is almost always at a premium, being able to convey complex information clearly, concisely, and persuasively through compelling visuals is absolutely invaluable. It empowers decision makers to quickly understand key performance metrics, intuitively identify areas of concern, and swiftly spot opportunities, without needing to sift through dense spreadsheets, interpret statistical models, or rely on lengthy verbal explanations. It really bridges that gap between raw data and executive action. And there are specific tools that truly excel at this. Some we've mentioned before, which just underscores the remarkable versatility. Power BI from Microsoft and Tableau are industry leaders, renowned for their robust capabilities in creating highly interactive reports, detailed analytics dashboards, rich data exploration experiences. They often integrate seamlessly with corporate data warehouses for those executive overviews. Kibana is frequently used in conjunction with Elasticsearch for visualizing vast amounts of log data and monitoring real-time events. Provides critical operational intelligence for IT teams, and Grafana, which we noted earlier for its powerful time series capabilities, is also an excellent open source tool for building dynamic, real-time operational dashboards, pulling data from various time series databases and presenting it clearly and flexibly to engineers and operations teams. Now, when it comes to best practices for designing truly clear, insightful, and actionable visualizations, it's about far more than just making pretty charts or, colorful graphs. It's fundamentally about clarity, ensuring labels are unambiguous, scales are appropriate and consistent, and visual clutter is rigorously minimized. Keep it clean. It's about insight. Meticulously designing the visualization so that it directly answers a specific business question or unequivocally highlights a critical trend. Make the key message undeniable. And crucially, it's about actionability, ensuring the visualization doesn't just display a problem or a trend, but ideally points towards potential solutions, suggests next steps, or directly triggers a decision or an intervention. The ultimate goal is always to ensure these visualizations truly serve decision-making, empowering users to move swiftly from comprehensive understanding to decisive action.
Okay, so we've covered the data explosion, the power of analytics, the tools to wield that power, and how to make the insights visible and understandable. But what does this all actually mean for real companies out there? Do these theories about data deluges and powerful analytics really play out in the messy, complex, high-stakes, real world? Are there tangible, measurable benefits, or is it all just, compelling talk? Thankfully, the answer seems to be a resounding, unequivocal yes. Let's look at some real-world case studies, true success stories that bring this entire concept to vivid life and demonstrate undeniable value.
Yes, these real-world examples are precisely what provide the tangible, irrefutable evidence. Evidence that IoT analytics isn't just a theoretical concept or some buzzword, it demonstrably delivers significant, measurable value. Value that impacts an organization's bottom line and its operational efficiency. They showcase how the intelligent integration of smart devices, continuous data collection, and insightful analytics directly translates into strategic advantage. Consider the manufacturing sector. It's been a pioneering and highly successful early adopter of IoT analytics. We've seen compelling examples where a major factory implemented a dense network of vibration and temperature sensors on its critical machinery, everything from robotic arms to large-scale presses. These sensors continuously fed torrents of high-frequency data into an advanced IoT analytics platform. By analyzing the subtle, evolving patterns in this data using machine learning algorithms, the system could predict with a remarkable accuracy when a specific piece of equipment was likely to fail, and not just fail, but fail weeks or even months before it actually broke down. This allowed the factory to schedule maintenance proactively during planned, minimal impact downtime, rather than reactively, in the midst of a critical production run. The result: a remarkable 40% reduction in unplanned equipment downtime. 40%. That's a direct, quantifiable impact on productivity, massively reduced emergency repair costs, eliminated lost production revenue. This is a quintessential illustration of how predictive maintenance, powered by granular IoT analytics, translates into incredible operational resilience, significant cost efficiency, and a tangible competitive edge. Then there's agriculture, an industry often perceived as traditional, maybe slow to change, but it's being fundamentally revolutionized by IoT. Smart irrigation systems are a perfect, impactful example here. These aren't just systems that water on a rigid timer. No, they're highly intelligent networks leveraging a diverse array of data. They use precise soil moisture sensors embedded right in the fields, along with real-time weather data from local stations and even localized weather forecasts, determine precisely when and how much water is optimally needed for specific crops in specific microclimates. This precision agriculture approach, meticulously driven by IoT analytics, has led to a verified 30% saving in water usage for some farms in water-stressed regions. 30%. Now, beyond the immediate financial savings from reduced water bills, this is a monumental win for sustainability and resource efficiency, especially vital in areas facing increasing water scarcity. It demonstrates how IoT can help us optimize our most precious natural resources on a grand scale. And in logistics and industry where efficiency, timeliness, and cost control are absolutely paramount, IoT analytics is a true game changer. Take the example of a large fleet management company. They equipped every single one of its delivery vehicles with real-time tracking devices and engine diagnostic sensors. These devices collected continuous data on GPS location, vehicle speed, precise fuel consumption rates, tire pressure, even detailed engine performance parameters, all streamed in real time. By integrating this rich stream of data with real-time traffic data, weather conditions, and customer delivery schedules, the company's analytics platform could dynamically optimize delivery routes on the fly. Instantly. This meant dispatchers could immediately reroute drivers around unexpected congestion, identify the most fuel-efficient paths for each vehicle, and proactively ensure deliveries arrived punctually. The impact was clear and profound, significantly increased punctuality, which dramatically boosts customer satisfaction and loyalty, and substantial lowered fuel costs across the entire fleet, directly improving profitability. This showcases how IoT analytics fosters operational excellence, enhances customer service, and provides a clear financial return. And these aren't just isolated incidents, These are representative success stories. They underscore the transformative power and tangible value of IoT analytics across countless industries. From heavy industry to environmental management and complex service delivery, it's widespread.
Okay, we've talked about the incredible potential and those impressive, tangible success stories. They really showcase how IoT analytics is truly reshaping industries. But no technology, no matter how revolutionary, comes without its inherent challenges, right? It's certainly not always a smooth ride to data nirvana, let's say. So what are the primary hurdles organizations must realistically acknowledge and then strategically overcome to truly harness the full power of IoT analytics?
You're absolutely correct. While the potential is indeed immense, there are definite, significant hurdles. Hurdles that organizations must be acutely aware of and proactively plan for if they want to ensure success and avoid costly missteps. Being forthright about these challenges and having a strategy to mitigate them is crucial. First, and arguably paramount, are data security and privacy. This is huge. IoT devices collect an enormous, often intimate amount of data, frequently from highly sensitive environments. Think personal homes, critical industrial control systems, or even patient monitoring in healthcare settings. Very sensitive stuff. Ensuring that this data is rigorously encrypted both in transit as it travels across networks and at rest and storage, and that stringent access control mechanisms are meticulously in place, is not just a best practice, it's an absolutely critical imperative. Non-negotiable. A data breach in an IoT system can have incredibly severe consequences, ranging from profound privacy violations and reputational damage to critical operational disruptions or even physical safety risks. The attack surface of an IoT deployment is vast, demanding a comprehensive security posture from day one. Second, there's integration complexity. This trips up a lot of projects. Many established organizations operate with older legacy systems, existing ERP systems, traditional databases, or specialized operational technology, OT, systems and factories. These systems were simply not designed to communicate seamlessly with modern, agile IoT platforms. They weren't built for it. Bridging these disparate systems, making them talk to each other effectively and reliably, can be a significant engineering challenge. It often requires meticulous planning, custom development, and robust middleware to ensure data flows smoothly and consistently from the edge devices through the analytics engines, and then integrates back into existing business workflows and decision-making processes. This isn't just about data format conversion, it's about protocol compatibility and workflow synchronization too. It's complex. Third, data quality. This is a persistent and often underestimated challenge. Raw sensor data, despite its volume, isn't always pristine, far from it sometimes. You inevitably have to contend with noise, irrelevant, or extraneous data. Inconsistencies in readings due to sensor calibration issues, intermittent connectivity, or even missing values due to network glitches or temporary sensor malfunctions. If your input data is of poor quality, garbage in, garbage out, as the saying goes, your analyses will inevitably be flawed, leading to inaccurate insights and ultimately poor or even detrimental decisions. Rigorous data cleansing, validation, and pre-processing become absolutely vital steps in the IoT analytics pipeline to ensure data integrity. Finally, scalability. This is an ongoing, evolving challenge. As the number of connected devices inevitably explodes and the volume of generated data grows exponentially. Managing the underlying infrastructure, whether it's servers, storage arrays, network bandwidth, becomes an increasingly complex and resource-intensive task. Organizations need to design and implement systems that can effortlessly scale up or down to handle increasing or fluctuating loads without collapsing under pressure or becoming prohibitively expensive. This demands careful foresight, robust architectural planning, and often a deep understanding of cloud-native elasticity. But these challenges, while real, are certainly surmountable. And our sources provide some highly actionable tips for success, gleaned from industry experience. One key piece of advice is to start small with pilot projects. Don't attempt to roll out a massive, enterprise-wide IoT analytics solution from day one. That's usually a recipe for disaster. Instead, identify a specific, well-defined problem or a high-value use case within your operations. Implement a focused pilot project, learn invaluable lessons from it, refine your processes and technology choices, and then scale gradually. This iterative approach minimizes risk and builds crucial confidence. Another critical tip is to invest in cross-functional teams. This is so important. IoT analytics isn't solely an IT problem or solely an operations problem. It fundamentally spans both. And often business strategy, too. You need to foster teams that seamlessly combine deep data expertise, data scientists, data engineers with profound domain knowledge. For example, data scientists working hand in hand with manufacturing engineers. They can ensure the insights derived from vibration sensor data are not only technically sound, but are also genuinely relevant and actionable for the factory floor. This blend of skills ensures that the analytics are not just technically brilliant, but also practically valuable and impactful. And finally, focus strategically on building reusable data pipelines. Instead of creating a bespoke, one-off data flow for every single new analytics project or use case. Aim to build modular, standardized, and reusable components that can efficiently ingest, process, and store data. This approach significantly streamlines data flow, dramatically reduces redundant effort, and makes it vastly easier and faster to deploy new analytics initiatives in the future. It's about establishing a robust, flexible, and scalable foundation that really accelerates future innovation.
Right, that makes a lot of sense. Start small, build the right teams, focus on reusability. Practical advice. Now that we've thoroughly navigated the obstacles and learned how to mitigate them, let's gaze into the crystal ball a bit. What's next for IoT analytics? How are cutting-edge technologies and evolving user demands not just influencing but actively shaping its very future? Where is this all heading?
The future of IoT analytics is incredibly dynamic. It really is. Constantly being reshaped by breathtaking technological advancements and increasingly sophisticated user demands. It's moving towards even greater autonomy, greater intelligence, and a deeper, more seamless integration with our physical world. A monumental trend is the even deeper and more pervasive integration of AI and machine learning. We're rapidly moving beyond just descriptive analytics understanding what happened and even predictive analytics forecasting what will happen towards truly prescriptive analytics, which tells us what we should do to achieve an optimal outcome. AI and ML are enabling far more sophisticated capabilities, things like advanced predictive maintenance that can not only tell you when a machine might fail, but also recommend the precise optimal time for maintenance, suggest the exact parts needed, and even automate the creation of a work order. Even more exciting, I think, is the move towards truly autonomous decision-making, where smart systems can adjust themselves and optimize operations without constant human intervention. Imagine a smart building that autonomously optimizes its energy consumption based on real-time occupancy data, precise weather forecasts, historical usage patterns, all without a human needing to tweak the single setting. This moves from insights directly to automated action. It's a big leap. We briefly touched on edge computing earlier, but edge analytics is taking that concept to an entirely new level. Instead of just processing data at the edge analytics means performing the actual analysis, running complex AI models and algorithms directly on the devices themselves or on local gateways, literally meters from where the data is generated. This significantly reduces data latency, allowing for near instantaneous responses to critical events, which is absolutely vital for applications like autonomous vehicles where decisions must be made in milliseconds, or in critical industrial control systems where real-time safety measures are paramount. It also drastically lowers bandwidth costs because less raw data needs to be constantly streamed back to the centralized cloud. It's basically distributed intelligence at its most impactful. Another profoundly fascinating development is the concept of digital twins. This is really catching on. A digital twin is essentially a sophisticated virtual replica of a physical system or an object or even complex process. It's a living, breathing digital model that is continuously and dynamically updated with real-time data streaming from its physical counterpart via IoT sensors. These highly accurate twins can then be used to simulate complex scenarios, predict performance under different conditions, and optimize operations entirely in a virtual environment before making any actual real-world changes. For example, a digital twin of a complex manufacturing line could simulate how adjusting robot arm movements or conveyor belt speeds affects throughput and energy consumption, allowing engineers to optimize the real line without disrupting production. Very powerful. Or a twin of a wind turbine could simulate how different blade angles or wind speeds affect energy generation and long-term wear and tear, allowing operators to optimize performance and schedule maintenance virtually. It's a powerful tool for continuous predictive modeling, proactive maintenance, and highly optimized operations. And finally, there's a rapidly growing and incredibly important trend toward using IoT analytics to drive sustainability initiatives. As organizations and governments increasingly prioritize environmental responsibility and climate action, .ot data becomes an absolutely invaluable asset for transparently tracking energy efficiency, meticulously monitoring resource consumption like water and raw materials, and accurately measuring carbon reduction efforts. Smart buildings leverage advanced analytics to dynamically optimize HVAC systems, lighting, ventilation to dramatically reduce energy waste. Smart cities use real-time traffic and waste data to manage refuse collection routes more efficiently, directly reducing vehicle emissions. It's about leveraging granular, real-time data to make operations greener, more resource efficient, and contribute meaningfully to broader environmental goals, turning sustainability from, a vague aspiration into a measurable, achievable outcome.
Wow, what a truly incredible journey we've just completed. Really comprehensive. We started by grappling with the sheer explosion, that unprecedented deluge of IoT data, then swiftly moved into how powerful analytics transforms that raw information into truly actionable intelligence. We explored the indispensable toolkit that makes it all possible, distinguished between the critical needs of real-time and historical insights, and highlighted just how vital effective visualization is to making complex data truly speak, making it understandable. We then grounded these theories with compelling real-world success stories across manufacturing, agriculture, logistics, unequivocally proving this isn't just theoretical potential, it works. And finally, we candidly acknowledged the significant challenges from security to scalability before gazing into that fascinating transformative future. A future of AI-driven autonomy, edge analytics, living digital twins, and profound sustainability impacts.
Indeed. What we've clearly seen today, I think, is that data analytics serves as the essential, sophisticated bridge, transforming what might otherwise be just a cacophony of IoT signals into genuinely impactful strategic decisions. It is the core mechanism that turns raw information into a clear, sustainable competitive advantage. So, As you consider your own journey or maybe your organization's path in this increasingly connected world, here are some key takeaways that our deep dive has really underscored. First, always meticulously choose analytics tools and platforms that genuinely align with your team's specific strategic goals, your existing infrastructure, and importantly, your capabilities. Don't simply pick the most popular option, pick the right one that fits your unique context. Very important. Second, remember that real-time and historical analytics, while distinct in their immediate purpose and technical demands, serve highly complementary roles. Integrating both provides a truly holistic, comprehensive view that empowers more robust, informed decision-making. Get the full picture. Third, never, ever underestimate the indispensable power of visualization. It truly makes or breaks the impact of your data. A meticulously designed, insightful dashboard can communicate more profound truths and trigger faster action than 1,000 raw spreadsheets ever could. And finally, focus relentlessly on building scalable, secure, and strategically aligned analytics approaches. This foresight will effectively future-proof your IoT initiatives, ensuring they can not only grow but also adapt and thrive as technology continues its rapid evolution, because it will evolve. Whether you're building an innovative IoT product, managing critical infrastructure, or scaling complex industrial operations, mastering IoT analytics can unequivocally be your secret weapon for driving sustained success in this increasingly interconnected age.
That's a great summary, a real secret weapon. And it leads me to the final thought. As AI and these dynamic digital twins become more and more intimately integrated with our physical world, creating these virtual replicas that are constantly perfectly in sync, how might our very own understanding of real-time and prediction need to evolve? What fundamentally new questions will we start asking ourselves as individuals, as societies, when literally everything is truly talking, and we possess a perfect, continually updating digital mirror reflecting our entire physical reality? Something truly profound to ponder as you go about your day, surrounded by all those silently communicating devices. Thanks for joining us on this deep dive. Keep digging for those insights.